guys, welcome once again to another fascinating math video. We are going to consider a problem from trigonometry and integration. Before we go over to the solution of the problem on the board, I want to inform you that I render a private online math tutoring service for primary level students, pupil rather, secondary level students, and college level students. So if you are in need of my service, be free to get across to me. I also offer services remotely for schools. That is remote services. If your school need a math tutor, I'm very qualified candidate for that service. So be free to get across to me. All right. Now we want to look at the solution of this problem on the board. To prove that the cosine of theta over 1 plus sine of theta plus 1 plus sine of theta over cosine of theta is equal to 2 seconds of theta. Now I want to show that the left-hand side is equal to the right-hand side. So what we shall do, we can write proof. Don't forget, it says enhance, evaluate this. That is, after we've established that this is equal to this, we should use that idea. That is, the word hence means use the idea that has been established to evaluate this integral. So if you see hence, that means you are conditioned to use the previous idea, the preceding idea. But if you say hence or otherwise, it means you have the liberty to use any other method of your choice. So if you are at an exam problem, if you see the word hence, you are mandated to use the previous idea. But if you see hence or otherwise, it means you have the liberty to use any other method of your choice. But this time around, you are mandated to use this knowledge to establish this result. So let us first establish this result first. Now, I want to show that the cosine of theta over 1 plus sine of theta plus 1 plus sine of theta over cosine of theta is equal to this. So we have cosine of theta over 1 plus sine of theta plus 1 plus sine of theta over the cosine of theta. Now, what we shall do here, we shall take the LCM, all right? And the LCM of these two expressions is written as cosine of theta multiplied by 1 plus sine of theta. Can you see that? Now, if this should divide into this expression, we are left with this. And this multiplying this, we have the result as cos squared theta. All right? The same thing applies here. This divides into this expression. We are left with this expression. And this binomial expression multiplying this here, we have the result as 1 plus sine of theta all squared. Can you see that? Now, what we shall do, we shall expand this binomial. So we have it as cosine squared of theta plus, on expansion, this becomes 1 plus 2 sine of theta plus sine squared of theta, all divided by cosine of theta multiplied by 1 plus sine of theta. Can you see that? All right. Now, recall from trig identities that the cosine squared of theta plus the sine squared of theta, that will give us 2 as a result. So that means I can write this fraction as 2, or rather, cosine squared of theta plus sine squared of theta is 1, right? Shall have 1 plus 1, then plus 2 sine of theta, all divided by cosine of theta multiplied by 1 plus sine of theta. And this can be written as 2 plus 2 sine of theta over cosine of theta multiplied by 1 plus sine of theta, all right? So we can factor out 2 here. When I'm bringing it out, we have 2 multiplied by 1 plus sine of theta, all divided by cosine of theta multiplied by 1 plus sine of theta. From whence this we divide out with this, all right? So we're left with 2 over, or you can write it as 2 times 1 over cosine of theta. And the reciprocal of the cosine is the seconds, all right? So this becomes 2 seconds of what? Of theta. So we've been able to show that this expression here, you are seeing here, this partial expression is equals to 2 second of theta. So the first mandate has been done. So we want to go to the second aspect. We are required to show that the integral of sec theta, in order to evaluate the integral of a secant of theta rather. Can you see that? I want to do that from this preceding expression because of the word hence. So how do we go about it? Now, don't forget that We can say now cosine of theta over 1 plus sine of theta plus 1 plus sine of theta over cosine of theta is equal to 2 seconds of theta. So what we shall do, we shall divide both sides by 2, all right? So if we do so, we have that the secant of theta is equal to 1 over 2 multiplied by cosine of theta over 1 plus sine of theta, all right? Plus 1 plus sine of theta over cosine of theta. So we have this at hand, right? So what we shall do, we integrate both sides with respect to theta. So in doing so, we have the integral of secant of theta, the theta equals to, now since this is a constant term, we can factor out it out of the integral sign. So we now have it as half multiplied by the integral of cosine of theta over 1 plus sine of theta plus 1 plus sine of theta over cosine of theta, all right? With respect to theta. Can you see this? It sounds interesting, all right? We are almost there at the results. Now, listen, let's do something interesting here. Now, observe carefully that if you differentiate this denominator expression, before we do that, let us, because integration satisfies the linearity property, we can write this as half, curly brackets, then we can take this, we can integrate 10 by 10, all right? So we have the integral of cosine of theta over 1 plus sine of theta with respect to theta, right? Then plus the integral of 1 plus sine of theta over the cosine of theta with respect to what? To theta. Can you see that? So I will wipe this out of the board now. Having this done, let me wipe it out of the board. Now, observe carefully that if you differentiate this denominator, if you differentiate 1, you have 0 as a result. If you differentiate sine of theta, you have a cosine of theta. And that is exactly what is at the numerator. So if you differentiate the denominator, you shall have the what? Numerator. So because of that reason, there's a law that says that if we have the integral of 1 over x, the x is equal to log of the denominator, log to the base e of x, then plus an arbitrary constant. Because if you differentiate x, you shall have 1, all right? And 1 appears as the numerator. So the law says that whenever the derivative of the numerator is that of the denominator, you take the log of the denominator. That is the law, all right? I repeat again. If the derivative of the denominator is a numerator, so the integral of such an expression becomes the log of the denominator. So we shall apply this concept in this particular aspect, all right? So if you differentiate 1 plus sine of theta, you shall have cosine of theta. And looking at the numerator, you see the results there. That means that the integral of this fraction is a log, the natural log of the denominator. So in that case, we have the result as half brackets. So instead of writing this expression, I will have log to this e of 1 plus sine of theta. Can you see that? Then plus. Now, this expression can be written as 1 over cosine of theta plus sine of theta over the cosine of theta. All right, with respect to theta. Can you see that? Now, this can now be written as half log to this e of 1 plus sine of theta plus, using the linearity property of integration, we have it as the integral 1 over cosine is a secant, right? Secant of theta plus the sine over cos is what? That will give us a tan, right? We have tan. But we can leave it like that. It's not big deal. We can write this as minus integral minus sine of theta over cosine of theta. Do you agree with that? Look at it. Minus times minus will give us plus. So it's not different. It's the same thing. All right? There's a reason why I insert the minus. I will explain shortly. So now expanding by this coefficient here, we have it as half log to this e of 1 plus sine of theta plus half of the integral of sec theta. Then let's come over here. Now listen. If you differentiate cosine of theta, you shall have minus sine of theta. So you see the reason why I introduced the negative sign. That is the reason why. I foresee this and I have to do it immediately. All right? So we have the derivative of cosine to be negative sine. So from the law I just quoted, I quoted that 4 times. This result becomes the log to base e of cos theta. All right? Can you see that? So the only trouble is sec theta. And don't forget, initially we are required to find the integral of sec theta. All right? Do you remember that? And that is what took us to this. As we look at it, sec theta equals to this, and this equal to this, equal to this, equal to this. All right? So what we shall do, we shall take this expression to this left-hand side. You may be confused, so let me do it a bit neater. So I can write this. Therefore, the integral of secant of theta with respect to theta is equal to 1 over 2 log to base e of 1 plus sine of theta plus half of the integral of secant of theta minus log to base e of cosine of theta. Hope you can see that. All right? This cosine. So what we'll do, we'll take this expression to this other side because they are alike. All right? So if we do that, we have it as integral of secant of theta d theta minus half integral of sec theta d theta. Please put d theta here. All right? Then equal to half times log to the base e of 1 plus sine of theta minus log to base e of cosine of what? Theta. So this is just a normal fraction, all right? This is a normal fraction. So if we simplify this fraction you are seeing here, or if it is difficult for you, take integral of sec theta d theta to be x, all right? If it is x, we shall be having x minus half of x. And of course, you can simplify this. 2 times x will give us 2x minus x, so you have x over 2 as an answer. So in other words, this expression you are seeing here can be written as 1 over 2 integral of sec theta d theta. That is the meaning. All right? It's very, very simple. For example, 1 minus half will give me half. All right? So integral of sec theta minus half of it will give you the other half of it. So that is what you are seeing here. Can you see that? All right. So in this case, we have this to be equal to 1 over 2 log to base e of 1 plus sine of theta minus log to base e of cosine of theta. So we are already there at the result. What we shall do is to multiply both sides by 2. All right. So if we do that, we have the answer. Let me erase this part of the board. So now on multiplying both sides by 2, we now have, therefore, the integral of secant of theta is equals to, multiply this term by 2, you have the result as log to base e of 1 plus sine of theta. Then multiply this expression by 2. Now when multiplying, you multiply every expression in the equation, or otherwise the expression become an inequation, no longer equation, no longer equation, become an inequation. So endeavor to multiply each of the term by the constant you choose to. All right? So if you multiply here, you have minus 2 log to the base e of cosine of theta, then plus c. And this is the result. We can simplify if you like, but I would like to stop here. So we've come to the end of this fascinating math video. Do me a favor to like, share, and make your comments. And don't forget that I offer a private online math tutoring service for primary level, secondary level, and even to the college level. And I also run services for schools. So be very free to get across to me if you need a remote service. Thank you very much. Till we meet again. Bye.